Hello everyone. Hi. My name is Nurfatin Nazira binti Abdul Razak. Have you ever seen this symbol before? What is it? Yeah, this is about radioactive. Today, we're gonna learn radioactive radiation and half-life in 15 minutes. Let's get to it. Before we start, let me introduce you about this topic. This is from the topic 8, Radioactivity for Form 3 Science KSSM syllabus. This is under the subtopic 8.1, which is History of the Discovery of Radioactivity. So our learning outcome for today is, at the end of this lesson, you will be able to explain with examples radioactive substance, radioactivity, and the concept of half-life. So our three key points here is radioactive substance, radioactivity, and the concept of half-life. We're gonna see the concept one by one. Let's move on to radioactive substance. What is radioactive substance? Radioactive substance is the elements that have an unstable nucleus. What does it mean by unstable nucleus? A nucleus becomes unstable because of the strong nuclear force that holds the nucleus of the atom together is not balanced with the electric force that wants to push it apart. Radioactive substance, also known as the elements of a substance with a heavy nucleus where its atomic mass is relatively high. The radioactivity elements present in the periodic table start with numbers larger than 84. For example, like radium-88. Now, let's have a look at this picture here. You can see there is a nucleus that consists of proton and neutron. So the proton is the red one and neutron is the white color. Electromagnetic force of proton pushes each other away from nucleus. Meanwhile, the strong nuclear force holds the element of the nucleus together, while the protons push each other away from nucleus because they are in unstable state. So because of the nucleus is unstable, the atom will decay into more stable ones to become stable, and unstable nuclei emits particles. So, the process of emitting energy by the nucleus of a radioactive atom in order to become more stable is called as radioactive decay. Now, let's move on. What is radioactive decay? Radioactive decay is a random and spontaneous process where an unstable nucleus emits radioactive radiation until the nucleus becomes more stable. So another example of radioactive elements that have unstable nuclei and decay spontaneously by emitting radioactive radiation are as follows: carbon-14, radon-222, thorium-234, and uranium-238. The length of time taken for a radioactive substance to become stable and non-radioactive varies from substance to substance. Now, let's move on to radioactivity. Radioactivity is a random and spontaneous decay process of an unstable nucleus by emitting radioactive radiation. I repeat, unstable nucleus. Radioactive radiation consists of number 1, alpha particles, number 2, beta particles, and number 3, gamma rays. Here you can see the symbol for alpha, beta, and gamma. Now, what is the unit of radioactivity? The unit of radioactivity is, you can see here, there are two, Curie and Becquerel. The first unit of radioactivity introduced was Curie. The rate of unstable nuclei decay or activity in nuclei decay is measured in Curie. 1 Curie is 3.7 times 10 to the power of 10 decays per second. That means the Curie approximately the number of decays per second. So the SI unit of radioactivity is becquerel. 1 becquerel equals to 1 decay per second. Let's have a look at the examples of radioactive radiation. Remember, we have three types of radioactive radiation: alpha particle, beta particle, and gamma rays. So this one is for alpha particles. So the example that I choose here is a decay of uranium-238. Uranium-238 consists of proton number, 92 proton number, and 146 neutron number. When you sum up these two, you're going to get uranium-238. Okay, uranium decay into thorium. Thorium that consists of 90 proton number and 144 neutron number. When you sum up the proton number and neutron number, you're going to get the total mass of thorium 234. Plus, the other product of the decay is helium nucleus. So the total mass of helium is 4 because 2 proton number plus 2 neutron number. So if you can see here, the total mass of uranium before the decay and after the decay is still the same. Okay, we're still gonna get 238. Here is example for beta radiation. Okay, thorium 234. So actually it is the continuous from the previous example, which the decay of uranium into thorium. So here thorium 234, again that consists of 90 proton number and 144 neutron number. So when you sum up these two, you're going to get the total mass of thorium 234. The thorium decay into protactinium 234. Already have the same total mass number. The difference here is the proton number. As you can see here, the proton number of protactinium increased by 1. The other product of thorium decay is electron. So here is the beta particles. Here is another example of radioactive radiation, and this one is for gamma ray. You can see here, before the decay, the cobalt-60 nucleus is less stable. So when it is unstable, it will decay into more stable nucleus. So when the decay happens, it has the product of cobalt-60 and plus gamma ray. So cobalt-60, nucleus of cobalt is more stable after the decay. We already see the example for 3 radioactive radiation, which are alpha particle, beta particles, and gamma ray. Now we're gonna look at the half-life. What is half-life? Half-life, T-half, is the time taken for the number of undecayed nuclei to be reduced to half of its original number. Okay, half-life is actually the time required for a quantity to reduce to half of its initial value. For example, like if the initial value is 80, and then the half of it is 40, and then half from it is 20. Later on, we're gonna see what is the concept of half-life. Okay, the term is commonly used in nuclear physics to describe how quickly unstable atoms undergo or how long stable atoms survive radioactive decay. This is the example you can see. Shows the situation when the number of undecayed nuclei decreases with time. Okay, this one showed undecay and this one is decay. For the first half-life, it becomes half-half. So half undecayed and half decayed. And after the second half-life, 1/4 undecayed and 3/4 decayed. And the third half-life, it becomes 1/8 undecayed and 7/8 decayed. We're gonna see some example questions so that we're gonna become more clear about the half-life. Example question for half-life. Let's look at the questions number 1. Protactinium-234, Pa-234, decays to uranium-234 with half-life of 5.2 hours. Calculate the mass of Pa protactinium-234 after 20.8 hours with its original mass of 80 grams. Okay, it already said that the original mass is 80 grams. So the half-life for protactinium to decay to uranium is 5.2 hours. That means after 5.2 hours, the original mass of the protactinium become half, which are, let's have a look at the answer. So the original mass is 80 grams, and then after 5.2 hours it becomes 40 grams. And then after another 5.2 hours, so the mass of 40 will become half and become 20 grams. Again, another 5.2 hours, become more or less 10 grams, and finally become 5 grams. Because the questions want the mass of protactinium-234 after 20.8 hours. So the remaining mass of protactinium-234 after 20.8 hours is 5 grams. Another example for half-life. Okay, question 2. If the half-life of 100 gram radioactive isotope is 6 years, calculate the mass of radioactive isotope after 24 years. So the solution is, remember the original mass is 100 gram. So after 6 years, half of its original is the mass of the radioactive isotope, which is 50 gram. And then another 6 years, it becomes half of the mass 50 equal to 25 grams. And you need to calculate it until it for 24 years. So you're gonna get the final one is 6.25 grams. Thus, the remaining mass of radioactive isotope after 24 years is 6.25 grams. Now, let's see if you can answer 3 simple questions based on what we have learned before. What is the meaning of radioactive substance? What is the meaning of radioactivity? And what is the meaning of half-life? Before we end this lesson, let's answer the question before. What is radioactive substance? It is the elements that have an unstable nucleus. What is radioactivity? Radioactivity is a random and spontaneous decay process of an unstable nucleus by emitting radioactive radiation. And the last one is half-life. Half-life is the time taken for the number of decayed nuclei to be reduced to half of its original number. Okay, now that's the end of our lesson for today. Thank you for listening and have a good day. I hope to see you again in the next lesson. Thank you. Goodbye.